Good morning and welcome to Inner West Council Library. We present an HSC lecture series in partnership with First Class Tutoring. But before all, I would like to acknowledge the traditional custodian of the land on which we produce this series, the Gadigal and Wangal people of the Eora Nation, and show my respect to their elders past, present and emerging, and to all First Australian watching this series with us. Enjoy and good luck for your exam after a very, very hard year.
Hello, this is a presentation that summarises all the Year 12 content from the Mathematics Standard 2 course. So over to my first slide, and what we have here is a summary of all the topics and also the subtopics that will be taught in Year 12. Could I at this stage make the point that the HSC in the Mathematics Standard 2 course, as well as the trial exam, will be examining content from both the Year 11 and the Year 12 course. So my advice is that you are very familiarised with both the Year 11 and the Year 12 content. This presentation, as I've mentioned, will only cover some exemplar questions from the Year 12 course. As you guys can see, the Year 12 course is split up into 5 topics that branch out into some subtopics. What I've done in this presentation is that for each topic, I've themed it a different colour. Let's begin. So the first question is in relation to simultaneous equations. And they've given us 2 equations, and each of these equations contain 2 unknowns, commission, C, and the number of sales, which is N. Okay, and they've asked us to solve simultaneously. Now, when you solve simultaneously, you are after an answer for each of the variables. And in this case, the 2 variables that I need an answer for is C and also N. So let's begin. So I've been given CAF's commission formula, which is 0.14N plus 550. And what I'm going to do is so I'll call this equation 1. And what I'm going to do is I'm going to substitute equation 1 into equation 2, which is Frieda's formula. So let's call this equation 2 and this is equation 1. So in equation 2, whenever I see C, I'm going to replace it with what C equals in equation 1, which obviously is 0.14N plus 550 equals 0.34N. Now all of a sudden, I've gone from equations that contain 2 variables to one equation that contains the same variable, N, and I can actually solve that. So looking at this equation, I've got 0.14N equals 0.34N, okay? So N is mentioned on both sides of the equation. We always eliminate the variable with the smaller coefficient. In this case, 0.14N. And we eliminate it by taking away. So working from left to right, 0.14N take away 0.14N, they cancel each other out. I'm left with 550 on the left hand side. On the right hand side, 0.34 take away 0.14 is going to leave you with 0.2, and don't forget about the N. Alright, now to solve for N, you have to divide by the coefficient of the variable, and in this case I have to divide by 0.2. And what I end up is, if I do this calculation over here on my calculator, what I will end up with is 2,750. Now that's the first of my 2 answers, okay? And remember, N represents the number of sales. Okay? And so I'm still after the commission. Now I can substitute N into this first equation over here or into the second one. and you will still generate the same answer. I'm going to substitute it into equation 2. So 0.34, and when I see n, I'm going to substitute 2,750. Okay, when I do that, I'm going to get the commission is 935. Okay, in this case it's going to be dollars. Okay, and that's the commission. All right. So once again, when you are solving simultaneously, okay, you need to generate two answers, one for each of the variables, and you need to somehow link these two formulas. All right, now our next equation talks about the cost for a company as well as the income that the company makes from selling bags. And what we're after is this break-even point. Now, just reminding you that these two things can be linked by having a look at what's actually happening. So your income linear equation is a direct variation. So it starts at 0, 0. Okay. Your costing is going to start at, in this case, well, it's going to start at 75,000, and then it's going to increase that way. All right. Now, at some stage, these two equations are going to cross over. All right. And where they cross over is where I equals C, and that's called the break even. So the break even is where income equals the cost, and that's how we link up these two formulas. Okay, so this is break even. Before break even, the cost is more than income, so this is what we call a loss zone. Okay, and this is obviously the profit zone where your income is greater than your cost. Now, just whilst I've got this particular diagram up, last year they had a very, very interesting question in the Standard 2 exam where they had these two zones flipped around. So do look out for a really, really good question in the 2019 paper. All right, so let's actually start. So how am I going to link up these two formulas? Well, it's income, which is 800n, when it's equal to the cost, which is 50n plus 75,000. All right, so once again, what I end up with is an equation where the variable n appears on both sides. Remember what we did last time? We eliminated the pronumeral with a smaller coefficient. Okay, so in this case it's 50n. Now working from left to right, 800n take away 50n is 750n. 50n minus 50n is 0, so I'm left with 75,000 on the other side of the equation. And to work out what n is equal to, okay, to work out what n is equal to, I need to divide both sides by 750. Okay, and that will leave you with n is equal to 100 bags. Alright, and go back and reread the question. How many bags were sold? And n is the number of bags. Alright, so we've actually solved this particular question. Alright. Now, as you move on in this topic of types of relationships, you will move on from linear relationships to non-linear relationships. Let's have a look at our next example. At Paddy's Pizza, the cost of a pizza is proportional to the square of its radius. A couple of important words that I'd like to highlight. Okay, so the first word is proportional. So that's where we have two variables that are linked up by some sort of a constant. Now, what are these two variables? Well, go back and reread the first sentence. So I've got the first variable is the cost, and the second variable is the radius. All right, so let's reread that first sentence and let's try to link up the cost with the radius. All right, and it says the cost of a pizza is proportional. Now, whenever you see this word proportional, you must introduce this constant k, and it's proportional, so equals k to the square of its radius. So square of the radius is the radius squared, r squared. Now that's how these two variables are linked. Now what we're going to do is we're going to read the second sentence. It's going to give us a value for c and a value for r, and that will allow us to work out the value for the constant k. Right, let's read on. If a pizza with a radius of 10 centimeters, so let's substitute 10 for the radius, and remember it's 10 squared, cost $8.50. Alright, so by substituting for the cost and the radius, I can actually work out the value of this constant k. So 8.5 equals 100k. How did I get 100? Well, 10 squared. 10 times 10 is 100, multiplied by k is 100k. So I need to solve for the value of k. Of course, I would now need to divide both sides by 100. And so what I end up with is that k is equal to 0.085. Therefore, I'm going to substitute that back into this equation, and I will end up with c is equal to 0.085 r squared. Now this constant of proportionality that links up these two variables is 0.085. Alright, so I've done all of this work after reading the first two sentences. Now when you read on a little bit further, it's going to give you now something to use this formula to actually solve the final bit of the equation. So let's read, and it's asking us what is the cost of the pizza if the radius is 16. So I'm going to multiply by 16. Don't forget it is radius squared, so 16 squared. Okay, now when you do that, you're going to get 21.76. Great answer, but go back and reread the question, and it says round to the nearest 5 cents. So it's going to be $21.75. Alright, so please always remember to reread the question once you think you've got an answer to present. Alright, just as one last final check. Now, our next problem, once again, is a nonlinear relationship. Okay, so the number of computers C affected by a virus after n hours is C equals 6 multiplied by 2.98 raised to the power of n, where n is a positive integer. Now, straight away, one of the skills of this particular topic is to be able to recognize different equations. Right, now in this case, because n is a power, what we have is this exponential model. Now just a few words about exponential models, all right, or exponential functions. Okay, so first of all, you can either have an exponential growth. Okay, so this is an exponential growth, or you can have an exponential decay, something that decreases as time increases. All right. Now, the difference between these two models, so here it's like y is equal to a to the power of x. Now, a is a numerical base, okay? So in this case, a is 2.98. Now, when you've got growth, a is actually greater than 1. When you've got decay, so y equals a to the power of x, well, a is less than 1, but greater than 0, okay? All right. So hopefully, just by knowing just like these, few little things, okay, within this topic, you should be able to, navigate your way, around it. So let's have a quick look at our first question. Is this an example of exponential growth, and give reasons? Well, obviously, yes it is. So yes, and what's the reason? Well, the base, and in this case, the base is, the base, in this case, we're just going to put the base in brackets. So the base, which is 2.98, is greater than 1. And that's a great answer. It's not the only answer. Well, what are some other answers that you might consider? Well, you can actually make mention that yes, it is exponential. Now, why? So this is another answer. Well, why? Because as the value of n increases, c also increases. Okay, and it's actually increasing at a quicker rate than the value of n. Look, like some pretty good answers here. Okay. All right, so it's either one or the other. Preferably, I would go with the first answer. Okay. All right. Now, the next question is asking us how many computers are affected by the virus after 7 hours. So it's just a straight out substitution. So it's 6 lots of 2.98, and then it's raised to the power of 7. Now, when you do that on your calculator, you're going to get 12,521, okay, 0.7. Okay, but that's at 7 hours. So after 7 hours, we're going to round that up. And there's your answer. Okay, now for part 3, okay, it says how long will it take 50,000 computers to be affected by the virus, and then give your answer to the nearest hour. Rightio. So what we're going to do here is guess, check and refine. So we're going to have a guess. We're going to select the value of n, have a guess. We're going to check our guess to calculate the eventual value for c, and then we're going to refine it, either increase the value of n or decrease the value of n. All right. So, well, we know when n equals 7, the number of computers affected is 12,522. So that's under. Okay, so we're going to refine it by checking 8. Now when we check 8, when we substitute 8 into the value of n over here, what we're going to get is 37,314 computers. Once again, that's still under the 50,000 that they are asking us. So we refine it and we guess up. So our next guess is we're going to substitute n is equal to 9 there. And when we do that, we're going to get 111,198. Now that's way over, right? So in actual fact, after the 8th hour, it's going to reach that 50,000 computers that are affected. All right. But it says give your answer to the nearest hour. So is 50,000 closer to 37,000 or is it closer to 111,000? Very good. It is closer to 8 hours. So that would be a great answer after 8 hours. All right. All right. Now, on to our next topic. Now, please note the theme color change. Okay, so we're going from yellow to, pale pink. Okay, so now we're moving on to our next topic, which is measurement. And what we now have a look at is our first subtopic, which is non-right angle trigonometry. In this topic, you will need to have a very good understanding of what the sine rule is, what the cosine rule is, okay, bearings and angles of elevation and depression and all of those other things. Let's just quickly talk about the sine or the cosine rule. Now the sine rule basically works if you've got opposite angles and opposite sides that are given to you in a non-right angled triangle. The cosine rule basically works if you've got this V effect, right? So if you've got a side, an included angle, and then another side, okay? So it's like a V effect where the sine rule is more like an X effect. All right, so let's have a quick look at this question on this slide. And what we're after is find the correct value of X. So now we need to determine, do I use the sine rule or do I use the cosine rule? So let's have a quick look. What have we been given? Well, we've been given 3.5 and 42 degrees, okay? we've been asked to calculate x, but I don't have the angle opposite x. But that's okay, because I can actually work it out, because I've been given these other two angles. Alright, now 88 and 42, well, that's going to add up to 130. So if I do 180 degrees, because that's the angle sum of a triangle, take away 88 and take away 42, I'm going to end up with 50 degrees for this particular angle. So let's actually write in 50 degrees over here. Alright. Now by doing that, I now have this x effect where I've got opposite sides, opposite angles, and another opposite side, opposite angles. So let's actually substitute into the sine rule. By the way, the sine rule and the cosine rule, they are given to you on your reference sheet. It's just a matter of you, recognizing and also applying it. So let's begin. I'm after the side length x, so x goes on top, so it's x over sine of 50. And that's equal to 3.5 over the sine of 42. Okay, I want to know what x is equal to, so I'm going to multiply both sides by sine of 50. Okay, so on the left hand side, they are going to cancel each other out, and I'm left with x is equal to 3.5 multiplied by the sine of 50. Okay, and divided by the sine of 42. Right, make sure that your calculators are set in degrees, okay, and away we go. Enter that into your calculator and you should get the answer is 4. Alright, now our next question involves, lots of concepts. So the first thing we're going to do is that we're going to transfer some of the written data onto this diagram over here. So let's begin. A ship sails 6 kilometers from A to B. So has that been transcribed on the diagram? No, it hasn't. So let's do that ourselves. So from A to B is 6 kilometers. And it's traveling on a bearing of 121 degrees. So let's actually note that down. From the northerly direction to this line over here, we're going to have 121 degrees. Okay? Alright, it then sails 9 kilometers to C. Well, the ship is at B, it then sails 9 kilometers to C. The size of angle ABC is 114 degrees. So all of this angle over here is 114 degrees. Alright, so let's begin. What is the bearing of C from B? Now, when we're looking at bearings, it's always what it is from. So what is the bearing of C from B? So let's choose a different color. Okay, we are actually after, so this is B, so now we need to do a northerly direction. We are actually after this particular angle over here. Alright, and that should give you the bearing of C from B, right here. Okay, so how are we going to do that? Well, I'm going to take you back, all the way back to year 7. Alright, what am I going to do? I'm going to extend this northerly line, and then I'm going to extend it all the way down to the southerly direction, into the southerly direction. Now we know that from north to this line is 121 degrees, but we know that from north to south is actually 180 degrees. So to calculate this angle over here, and let's choose maybe like a different color, to calculate this angle over here, it's going to be 180 take away 121. Now, when I do that, I'm going to get 59 degrees over here. Alright, go back to blue, and take you back all the way back to year 7. So we've just done supplementary angles, but now what we're going to do is our alternate angles. So if this angle over here is 59 degrees, can you guys see the Z? So from there to there, all the way up to there. So there's a Z angle there, there's an alternate angle there. That means that this part of this angle, of this 114 degree angle, is 59. Alright? So I think just by doing that, it now falls apart. So So for question number 1, the angle theta is actually 114 degrees, take away 59. Alright. Now, what's that going to give us? Well, that's going to give us 55 degrees. And I'm happy with that, except I have not answered the question. So what's the question asking us? It's asking us for bearing. Now the bearing, okay, is always a 3-digit number. So 55 degrees is the size of the angle. The bearing is actually 0.55 degrees. And now that is your final answer. Okay. So now we'll move on to part 2. Let's change colours. And for part 2, we're after the distance A to C. So let's redraw our diagram. Okay, so this is 6 kilometers, this is 9 kilometers, this is 114, that's A to C. Let's call the distance here x degrees. Now what we have here is that V effect, alright? So I've been given the 6, I've been given the included angle, and I've also been given the 9, alright? So this becomes the value of A. The two sides around the included angle become the values of A and B. Right, yeah. So let's actually substitute. So I've got x squared equals A squared, which is 6 squared, plus 9 squared, minus 2 lots of 6 times 9 times the cos of the angle in the middle, which is 114 degrees. Now when I do all of that, I'm going to get 160.93. Okay, but that's the side, that's x squared. I want to know what x is. I want to know what AC is. So x is the square root of 160.93. Okay, and what will that give us? Well, that will give us 12.7 kilometers, which is the correct answer. Okay, but go back and reread the question. It's asking to the nearest kilometer, right? So we now need to refine it to 13 kilometers. Okay. And that's our final answer. So we're going quite well with this question, and now let's have a look at part 3. Okay, what is the bearing of A from C? So, what's the most important word there? Well, it's the from. So this is C, this is A, and what we're after is this bearing over here, right? So there's the northerly direction, and we are after this whole angle there, all the way to there. That's the bearing of A from C. Alright? Now what do I know? Well, I know that from north to south is 180 degrees. And just reminding you that we split up this angle here at B, previously we split it up into 59 and 55 degrees. Now, once again, using my knowledge of alternate angles, let's see if we can form a Z. So this line, and now go down this line. There's my Z, there's my alternate angle. So this line, this angle here is 55 degrees. So what I'm actually after is the angle inside this triangle. Because once I find this angle inside the triangle, I'm going to add 180 and 55 degrees. Okay, and I will have my bearing. Alright, so let's write in some of the other details. So I've got the 6, I've got the 9. I'm going to rub off this bit of information over here, and I'm going to replace that with the 114 degrees. Alright, and don't forget this worked out to be 13 kilometers. Okay, so 9 kilometers and 6 kilometers. Right, so I'm actually after this angle here theta. Well, I've got the opposite side that's been given to me, and then I've got the 114 degrees and the 13 degrees. So can you guys see that I've got this X effect happening? So therefore that's going to lead me to the sine rule right here. Okay, so I need to write a little bit small, so please bear with me. Right, so we've got sine theta over 6 is equal to the sine of 114 degrees over 13. Okay, now even though the correct answer is 12.7, okay, If you've used the correct answer from the previous question, they'll take that into consideration. All right. So carrying on, I'm going to multiply both sides by 6. Okay, so what I will end up getting is this expression over here. Sine theta equals 6 multiplied by sine of 114 degrees. Okay, and then divide that by 13. Now, you're after an angle, so you need to do the inverse sign. So sine -1 of 6 times sine 114 degrees over 13. So what will we end up getting for for theta, I beg your pardon? Okay, so we'll end up getting to the nearest degree. So I think the calculator answer comes out to be 25 degrees and 34 minutes, but to the nearest degree, it's going to be 26 degrees, right? So now we need to answer the question, and that is bearing equals, well, in this case, it's 180 plus the 55 plus the 26, and that's going to give us a bearing of 261 degrees. That's a that's a 3-digit figure, and that's correct. That's the final answer. So quite a bit of work combining everything that we know in non-right angled trigonometry. Okay, still on the same topic of measurement, we now move on to rates and ratio. Let's have a read of our first question. So a drug is to be administered to a patient at the rate of 2.5 milligrams per kilo of weight, and the drug is available at 60 milligrams per 5 milliliters. Now, how many milliliters must be given if the patient weighs 36 kilos? Right here. So, going to highlight a really important detail, and that this weight is administered at 2.5 milligrams per kilo of weight. Well, this person weighs 36 kilos, so he's going to get 36 lots of 2.5 milligrams. Okay, well, what does that give us? That gives us 90 milligrams. All right. The question is asking how many milliliters. All right. Okay, so I've got this rate over here, and it's 60 milligrams per 5 milliliters. Now I've been able to work out 90 milligrams, and we want to work out how many milliliters. So let's replace the unknown with an x. All right. So what am I comparing the same rate, milligrams to milliliters and milligrams to milliliters? Yes, I am. So let's proceed. So we'll go 60 over 5 is equal to 90 over x. All right. Okay, so 60 over 5 comes out to be 12 equals 90 over x. All right, what do I do over here? Well, I'm going to multiply both sides by x. And so I'll end up with 12x is equal to 90. Okay. And then dividing both sides by 12, I'll end up getting x is equal to 7.5 milliliters, which is the answer that I'm after. Okay, so another example of a rates question is something like this. A patient receives his medication through an IV drip at a rate of 18 drops per minute, and there are 16 drops per milliliter. All right. The patient requires 600 milliliters. So let's work out the number of drops. So for each drop, it says, so there are 16 drops in each milliliter. All right. So if the patient is receiving 600 milliliters, well, that's going to be 600 lots of 16. Okay, and that gives us 9,600 drops. Okay. All right. Now, Now, how do I link? So now it's asking us for how long it will take. Okay, so the time. All right. So do I have a rate that mentions, something to do with dot time? Yeah. Do I have another rate that mentions drops and time? Well, here it is here, 18 drops per minute. All right. So let's do that. 18 drops in 1 minute. So per minute is 1 minute equals 1,600 drops, and we want to know how long it's going to take. Well, let's compare the same units, so we want to know x minutes. Alright, so let's actually write up our two fractions. 18 over 1 equals 9,600 over x. Let's multiply both sides by x. And I'm going to get 18x is equal to 9,600. Okay, and then when I divide both sides by 18 to work out the time, I'm going to get x is equal to 533 and a third minutes. Okay, I think that's a good answer. Or you can go 533 minutes. Now a third of a minute is 20 seconds. Either or. That's a good answer. That's a good answer. Okay, now another question that you'll have to get a good understanding of is scale on a map or on a drawing. All right, now you've got two numbers. Now the first one represents the measurement on the drawing. The second number measures the real life measurement, or the actual measurement. Alright, and because it's a ratio, the units are the same. Okay, so two towns are 2 centimeters apart on a map. Okay, so what's the scale of our map? It's 1 to 500,000. Okay, and so we've got two towns that are 2 centimeters apart, so it's going to be 2 to x, because it's asking us for what is the actual distance between the two towns, but it's also asking it in kilometers. All right, now very, very quickly, of course a lot of you guys can see the answer right now, and the answer is going to be 1 million, but that's not the full picture. So just very, very quickly, so I've got x is going to be, okay, let's stay consistent. So I've got 1 over 500,000 equals 2 over x. Let's multiply by x. So that's going to give us x over 500,000 equals to 2. And then obviously multiplied by the 500,000, and that's how we get x is equal to 1 million. Now, that's not the answer though, because that's 1 million. Keep the units consistent. See the actual measure on the map is 2 centimeters. So the real life actual distance will be 1 million centimeters, but they're not after the answer in centimeters, they are after the answer in kilometers, right? So now we need to change that to, first of all, meters. All right, so we're going to divide by 100. Now when we're dividing by 100, let's just knock off 2 zeros. So that's going to give us 10,000 meters. And then from meters, we're going to go into kilometers. So we're going to divide by 1,000. So we'll knock off 3 zeros this time. And the answer is 10 kilometers. All right. Now, the distance between two cities is 75 kilometers. Now, that's the actual distance. So let's start off with our scale. 1 to 500,000. Okay, and how far are the two cities on the map? So we're after the actual distance on the drawing or on the map, so x, so that's the first number, okay? Back to what I explained right at the beginning. And that's 75 kilometers, right? But however, we can't proceed, right? Because the distance on the map is in centimeters, right? Where the actual distance is in kilometers. So we need to change this to centimeters, right? We'll do that first. So 75 kilometers, I need to multiply first of all by 1,000, and then I need to multiply by 100 to change it from kilometers to meters, and then to centimeters. Right, so how many zeros am I adding? 1, 2, 3, 4, 5. So the answer is going to be 7,500,000 centimeters. Okay, x, and then my actual scale, which is 1 to 500,000. All right. Okay, let's go. Change them both to fractions. 1, 2, 3, 4. Okay, 5. All right, and well, what do I do here? Lots of different ways to solve this, but what I'm going to do is I'm going to multiply both sides by 7,500,000. Okay, so do that on your calculator, and the answer is going to be 15 centimeters. So a nice little question there. Right. Now notice the theme change, so we're going now to a new topic, and obviously financial mathematics, and we are going to be working with investments and loans. Alright, so Ramon invests $6,000 for 3 years at 4.25% compounded quarterly. How much interest is earned? Now, this is what you would call a term deposit. So it's a one-off investment. You're leaving it alone, and then you're letting the bank, give you interest upon interest on this one-off investment. So of course, this type of investment is we apply the compound interest formula. So A is equal to P outside of 1 plus R to the power of N. Rightio, so A is the future value. Okay, P is the principal, which in this case is 6,000. R is the percentage rate, and N is the number of periods. The thing is that, see, my interest rate is per annum, but my compounding periods are actually per quarter. So first thing before I do is I need to manipulate both the values of R and N. So 4.25% per annum, I'm going to divide that by 4, and that's going to give me 1.0625% per quarter. 3 years, if I multiply that by 4 quarters for each year, I'm going to get 12 periods. And now I'm actually ready to substitute. So A, the future value, is equal to 6,000 outside of 1 plus the new value for R, and to the power of the new value for N, 12. Okay, so when I get this answer, I'm going to get $6,811.33. Okay, but remember that's my future value. The question is actually asking me for how much interest. So the interest is your future value, take away your actual principal. Alright, so please be careful, and when you think you've got an answer, go back and reread the question to see if that answer is what the question is asking. Alright, so in this case they're asking for interest, not for the future value, so you need to do just that one extra step. Okay, so let's have a look at this loan question. Lara bought an apartment. She had an $80,000 deposit and borrowed the remaining amount from the bank. So she actually borrowed $600,000. The interest rate is 3% compounded monthly and the repayments are $2,100 per month for 30 years. What is the total amount that Lara will have paid for the apartment at the end of the 30 years? Well, she's paying $2,100 per month. There are 12 months in a year and she's taken out this loan over 30 years. Now when you multiply all of that together, you're going to get $756,000. Okay, great answer, but it's not the final answer because remember, she's actually also paid an $80,000 deposit. Okay, so all up, what is the total amount that Lara will have paid? So all up, she will have paid $836,000 over the 30 years. All right, nice little question. Now complete the table above for the second month. So what we're after is this amount over here. Okay, remember her repayments are always $2,100, but interest in the second month is going to be a little bit less than $1,500. All right, so let's go all the way over here and let's work out our interest. I equals PRN. So how much does she owe at the beginning of the second month? Well, she owes $599,400. Okay, and interest is calculated at 3%. Okay, and I'm going to multiply that by 1 over 12 because that's just the amount for 1 month. Now when you do that, you're going to get $1,498.50. All right, and so the balance over here, well, it's going to be this sum. So how much she owes at the beginning of the month, we are going to add the interest and then we are going to take away her monthly repayment. And if you do that, you will get the correct answer is $598,798.50. And that's the answer. A great question. Okay, so this is another loan question, and what we have here is your ability to be able to interpret these types of tables. Okay, so let's read, and it says the table below gives the monthly repayment for $1,000 loan, reducing balance loan. Okay, so if I borrowed $2,000, I would need to double all of these. Okay, if I borrowed $10,000, multiply all of these factors by 10, and so on and so on and so on. All right, so Nick and Liz took out a mortgage to buy a house at 5% per annum, reducible interest for 20 years. Now the monthly repayment, so we're not after the monthly repayment, they actually give us the monthly repayment, 3168. Okay, the monthly repayment, okay, is $3,168, and what we want to know is how much was borrowed. So what do they give us? Well, they give us 20 years, so we're looking at this column, and they give us 5%, so we're looking at this row. All right, and obviously where do they intersect? At 6.6. So remember, your repayment for each $1,000 is $6.60. Okay, so I'm going to divide by $6.60, but don't forget I need to multiply it by 1,000. Now you do all of that and you're going to get 480,000, and that's how much they borrowed. All right, now an annuity is a different type of investment. an annuity depends on regular contributions, okay, that are made over a time period, and within that time period you're going to get recurring interest payments, and you're going to get interest on top of interest. So it's a good way of investing small amounts of money over a long period of time to get a real, good financial reward at the end of it. Okay, so let's read this table. The table below shows the future value of a dollar annuity at different interest rates and time periods. So if I had $1, okay, that's how much $1 would grow at all of these different interest rates over, these different time periods. Okay. And if I was investing that dollar, repeatedly, so that's the most important thing as well. Okay. So Jocelyn invests $2,000 every year at 4% per annum, compounded annually for 6 years. Okay, that's pretty straightforward because it's compounded annually and the interest rate is per annum. So we are looking at this column, the 4% column, and we're looking at this row, and of course, where do they intersect? Well, they intersect over here. Alright, so what is the future value of her investment? So she is making a $2,000 investment every year. So after 6 years, that all of those investments, okay, will have grown to 2,000 multiplied by 6.633 from the table. All right, and that amount will give us 13,266. That's a good question, okay? But I can also ask you some other things in regards to this answer. So for example, I can ask, well, how much interest did you earn from the bank? All right. So remember, if you wanted to calculate interest, okay, then it's the future value take away, the total amount of her investment, and the total amount of her investment is 6 lots of $2,000. Okay, because an annuity is a recurring investment. Okay, and here it says she's investing $2,000 every year for 6 years. All right, so try to make sense of the information that's actually given to you, like within the question, and also within the topic as well. All right, so number 2, Alana needs $20,000 for a vacation in 4 years' time. Now that's her future value. So now this time we're actually working backwards, because what we've been given is the future value, okay, and what we want to work out is her regular contributions. Okay, all right. So let's proceed. How much does she need to invest every 6 months? So it's no longer a yearly scheme. It's now a half-yearly scheme. All right, that earns 6% compounded half-yearly to reach her goal. All right. Well, 6% per annum will now become 3% half-yearly. So we are now looking at this column over here. All right, and 4 years becomes 8 compounding periods. So we are looking at this row over here. Where do they intersect? This 8.892. Now her future goal, all right, her target is $20,000. What we now need to divide is by this factor from within the table. So it's 8.892. And when we do that, we are going to be getting $2,249.21. And that means that she would need to invest this much each 6 months, and then after 4 years she'll be able to get this $20,000. Once again, we can ask you a question in regards to interest. Okay, how much interest does she earn from the bank to achieve this target? Well, it'll be the future value, which is 20,000, take away 8 lots of $2,249.21. Okay, something similar to what I showed in the first part. All right. Okay, note the theme change. So now we move on to statistics and bivariate data. Okay, so the first thing we're asking you about is what is the meaning of this correlation coefficient when it's at 0.12. Okay, just a little bit of background. So with bivariate data, what we are actually doing is comparing two different variables. Okay, and when we compare these two different variables, okay, what we will get is these scatter plots. Okay, now if the scatter plots, okay, are closely aligned and are increasing, then what we have is a high correlation coefficient. So our correlation coefficient over here could be, say, greater than, say, 0.8. All right. Okay, so over here then, okay, if they're like a little bit more scattered, but they still show some sort of an increasing trend, all right, what we have is like our correlation coefficient could be, say, anywhere between greater than 0.4 and say less than, say, 0.7. All right, and then over here we've got this like dots everywhere, and that could be anywhere from 0.25 all the way up to negative 0.25 or 3. All right, and that's what we have here, and then it goes the other way where you've got negative correlation, okay, and near perfect negative correlation. Okay, so your correlation coefficient actually fluctuates from 1, and it's got to be greater than -1. Okay, all right, now so over here we've got a correlation coefficient of 0.12. So really what that means is that there is no correlation or association between these two variables. And what are the two variables? Well, it's assessment results and height. Obviously, no relationship. Okay, so our next question talks about the least square lines of best fit, y equals mx plus c, where m is equal to this particular formula over here, the correlation coefficient multiplied by the standard deviation of y over the standard deviation of x. And c, the y-intercept, is the average of the mean of y, take away the gradient multiplied by the mean of x. Now, what is it asking us? Well, it's asking us for the gradient of the least square lines of best fit. So, in other words, I need to substitute into what they've given me, which is r multiplied by the standard deviation of y over the standard deviation of x. Now, what's the value of r? There it is there. And I'm going to be multiplying by 4.579. That's the standard deviation of y there. And the standard deviation of x is 1.987. Okay, put all of that into your calculator and you are going to get a value of m is equal to 1.9. Pretty straightforward. Okay, in this one, we're after a calculation that would lead us to Pearson's correlation coefficient. Now, obviously, you would need to use your calculator over here. And I'm only talking about the Cassia 82 FX or 100 FX. Okay, when I say that, first of all, you'll need to start off by pressing mode and then 2. Now that's the mode for bivariate data. Okay, you would enter all of these results first and then all of these results second. Okay, and then work your way across to calculating the correlation coefficient, and that's going to be 0.9907. Now that's pretty much near perfect, perfect positive correlation. So there's a high degree of a relationship between the hand span in centimeters and the forearm span in centimeters. All right. So you really need to learn to know how to enter these types of data into your table and to be able to work out Pearson's correlation coefficient. Okay, now the next subtopic in statistics is all about the normal distribution. Just a little bit of background for you. Whenever you read a question and you see something or a set of data is normally distributed, then straight away you need to think about this bell curve over here. All right, and in the middle of the bell curve, of course, you've got your mean. You also have your mode and your median, but in terms of normal distribution, we only deal with the mean and the standard deviation, which is what this question is asking. So let's read. It's got the mean of 900. Let's highlight that because that's really important. A mean of 900 and a standard deviation of 50. And what's the question asking us? Well, what is the best approximation for the percentage? So it's asking us for the percentage of bags that weigh more than 1,000 kilos. Okay, so let's actually draw something up. So there's my graph. Okay, it's mentioning that it's normally distributed. So there's my bell. Oh, sorry. Okay, so there's my bell curve. There, and then there. In the middle of it, I've got my mean, which is 900. As mentioned above, we always go 3 standard deviations above, and each standard deviation, it's mentioned that it's 50, so it's 950, 1,000 and 1,050. Okay, on the other side we're going to go 3 standard deviations below, so let's take away 50, 850 grams, 800 and 750. Okay, now on your formula sheet, you will see the same diagram over here, and what it's going to tell you is that 1 standard deviation away from the mean, which is from there to there, is 68% of all the scores. And when I divide that by 2, okay, because it is a symmetrical graph, I'm going to get 34% and 34%. 2 standard deviations away from the mean is 95% of all the scores. Okay, so 1 SD is 68, 2 standard deviations is 95. Now very, very quickly, what you would do is you would go 95 take away 68 is 27%, and divide that by 2 and you're going to get 13.5% on this side, 13.5% on this side. Okay, and 3 standard deviations away from the mean is 99.7. Now all of this data is given to you on your reference sheet. So you don't need to remember these numbers. All you need to do is to be able to split them up. What's the difference between these two numbers? Well, it's 4.7. Divide that by 2, you're going to get 2.35% and 2.35% over here. Then obviously 100% take away 99.7 is 0.3. Half of that is 0.15 and 0.15. Okay, and that's how you would fill in the percentage breakdown. Now, this question is asking us what percentage of scores lie more than 1,000 grams. So what percentage of bags have more than 1,000 grams? Well, more than 1,000 is this area over here, which of course is 2.35%, okay, plus 0.15%, which is obviously 2.5%. And that's your answer there, okay? Alright, another way of doing it could have been, well, from here to here is 50%, okay, plus 34%, well, that's 84%, and then plus another 13.5%, and that's your 97.5%, but what you're after is this area, this, proportion over here, so it'll be 100 take away 97.5. Once again, it's going to lead you to 2.5%. Okay, lots of different ways to tackle these problems. Okay, now the normal distribution shows the results of a mathematics assessment task. It has a mean of 60, so there it is, it's noted there. And a standard deviation of 10, we are going up by 10s, so plus 10, that's one standard deviation above the mean, two standard deviations above the mean, and three standard deviations above the mean. Now, this is one below, two below, and three standard deviations below. And the mean, these are all called standardized scores or Z scores. Okay, so that's my Z scale down the bottom, the one that I've added on. Okay, and it's based on the mean having a Z score of 0 and standard deviations above the mean having positive digits, and obviously below the mean negative digits. Now, there is also the Z score formula, so Z equals X minus X dash over the standard deviation. Alright, okay, so let's have a quick look. What is the mathematics assessment task with a Z score of -2? Well, you can either do it using the Z-score formula, or you can quickly interpret it from the graph. Okay, I'm just going to interpret it from the graph, and the answer is just simply 40. All right. Okay, over here, what is the Z-score of a mathematics assessment task of 65? Well, 65 would lie right in the middle of between 60 and 70, or right in the middle of your Z-score of 0 and 1. So obviously it's going to have a Z-score of 0.5, okay? But at this time, so we know that our answer is going to be 0.5, but this time we're going to use this Z-score formula. So the score that you've been given is 65, the mean is 60, and the standard deviation is 10, okay? So that's going to give you 5 over 10, which is obviously 0.5, okay? And lastly, what we have is, what is the percentage of results that lie in the shaded region? Well, remember, all scores below the bell curve or the normal distribution form 100%. And in this case, we are after this region over here, and then this region over here. This region over here in the middle is 68%. So I'm just going to take away 68%. And I'm going to get 32%. Alright, that's a nice little question. Alright, and so we've reached our last topic, which is networks. Okay, now this is a new topic for the Mathematics Standard course. There's not a lot of questions that you can practice on, because it wasn't a feature of the previous course, the general course. Okay, but if you look at say the VCAA papers, that's the Victorian curriculum papers, you can source out some really good questions. Okay, so there's a fantastic hint for a lot of you. However, some of the terminology and some of the things that are in their syllables are not, do not align with our syllables. However, please, you can still source some really good questions from there. Okay. Well, let's have a quick look at this particular question. So I've got 4 towns, they're all connected, and we're asking about the minimum spanning tree. All right, so for the minimum spanning tree, okay, what we have is, well, it's the number of vertices. So in this case, I've got 4 vertices. Okay, and so therefore for the minimum spanning tree, it's always n minus 1 edges. Alright, so it's going to be 4 minus 1 edges, which is, well, it's going to be 3 edges. So the 3 smallest edges, because we're after the minimum spanning tree. Okay, so we're going to start. Now, it'll be a good idea if you have a highlighter, okay, or a thick pencil, which, you can use to sort of like shade in, edges, okay? So we're going to start with the least weighted edge, which is this one over here. Okay, and we continue a lot, with this same pattern, but as long as we don't form any loops. Okay, so the next least weighted edge is the 12. And remember, I'm only after 3 edges, so we're after the next least weighted edge, which is the 14. Now, by following this rule and the other rule of not forming any loops, you have actually connected all the towns. So if I'm standing at town B, can I reach town A? Yes, by going this way. Can I reach town C? Yes, by going that way. And can I reach town B, town D? Yes, by going through town C. So all of the towns are actually connected. Okay? And you can do that. You can do this particular test for each of the, for each of the vertices. All right? Okay, so what is the length of the minimum spanning tree? Well, so therefore my answer is going to be 11 plus 12 plus 14, and that's going to give us 37, and in this case it's going to be kilometres. Okay, so over here we've got a network diagram, okay, and it's asking us for the minimum completion time for the above network. So minimum completion time. Okay, let's do a forward scan. All right, so we start over here. Now to complete activity A, it's going to take us 8 minutes, and to complete activity B, it's going to take us 3 minutes or 3 hours or 3 days. They haven't actually stated it. All right. Now, to get to this point over here, I can go through A and C, or I can go through B and D, all right? And because that's the end of a loop, all right, I'm going to write my answers outside before I choose the best option for inside. So watch and listen very carefully. So 8 plus 13 is 21. And let's stick to minutes, 21 minutes. Now, to go through B and D, it's going to be 13 minutes, all right? Now, what number do I put, okay, in this cell over here? Well, it's asking us about minimum completion time, right? So activity F cannot start until activity C or D has finished, all right? So therefore, I would need, even though I've finished 13 minutes going through this pathway over here, I would actually need to wait until activity C and activity A have actually finished. So there's wait time over here. And so therefore, I can't start activity F until after 21 minutes. All right. So when you're doing a forward scan, you're always after the maximum number whenever there's a loop. Right, now let's continue. If I want to continue to activity F, note that there's a loop because I can get to this junction over here by going through F or by going through G. Okay, so I'm just going to write my numbers outside, right? Okay, so 21 minutes plus 18 minutes is 39 over here. All right, or I can go from B to E, which will give me 26 minutes, and then E to G, 26 plus 5 is 31 minutes. Now what do I write in this cell over here? Well, even though I've gone along this pathway over here and it's taking me 31 minutes, I still need to wait for activity F to finish. I'm going to put 39 minutes because activity I cannot start until activity F and G have finished. All right. Just over here at the finish line. Okay, 39 plus 9, okay, is 48 minutes, but I need to write that on the outside because how else can I get to the finish? Well, I can do activity H this way. Okay, so 26 plus 13 is 39. And 39 plus 6 is 45. but what do I write inside this cell over here? Well, I would need to write 48. Okay, because even though activity J has finished, the whole project isn't finished until activity I is actually finished. And that's your answer. What is the minimum completion time for the above network? 48. It hasn't stated a unit. I believe I was saying repeatedly minutes, but as I said, it could have been days, could have been hours, not really sure. Okay. And so now we have our last question. And what we now have is not an activity, a network diagram like we have over here, but we've got this activity chart. And it's asking us from this activity chart over here to actually construct a network diagram. Okay, so let's choose our black pen. And let's choose the straight lines over here. Okay, so first of all, we have got 1, 2, 3, 4, 5, 6, 7, 8, 9 tasks in this project. Alright, and so we have a start vertex. Now, I'm going to be looking at this column over here. And what I notice is that activity A does not have a predecessor. So there's no predecessor for activity A. Alright? So therefore, activity A is the start of my project. So that's activity A. And what's the duration for activity A? Well, it's 5 hours. Now, please note that I haven't put an end vertex on it. Okay, I haven't put a dot on at the end of this line. Okay, because I don't know what flows out of A as yet. Alright? So all I know is that at the start, the first task that I need to do is activity A. Alright, so that's done. Now, activity B, the predecessor for B is activity A. That means I need to finish activity A first. So now I'm going to put my dot. Okay, and now I'm going to have activity B flowing out of activity A. Once again, I don't put an end vertex on activity B until I know what flows out of it. Now, how long is activity B? Well, it's 15 working days. Right, so far on this network diagram, I've done activity A and activity B. All right, now, have a look at this. Activity C, D, and E flows out of activity B. So now, when I finish activity B, I can actually start either activity C, activity D, or activity E. Alright, so C, how long is C? Well, it's 25 days. How long is D? It's 15 days. And E is 30 days. Now, once again, I haven't put any end vertices on any of these activities, C, D, and E. They're still very much open. Alright, so now I'm up to this activity F. Now, activity F flows out of, or the predecessor is C and D. Right, so I'm going to put a dot somewhere over here. Okay, and I'm going to flow activity D into here and activity C into here. That's the end of activity C and D. And from that flows activity F. So this is activity F. And activity F is 10 days in duration. Alright? Alright, so I've done that one. Now, I'm up to here. and what I see is activity G flows out of activity E and F. So let's put a dot, so somewhere here, and this is the start of activity G, and it flows after activity F and E have finished. Alright, so that's a little bit messy over here. So this is activity E, by the way. Alright, how long is activity G? Well, it's 10 working days. Alright, I'm up to here now. Activity H flows from activity G, so there's H. Once again, I don't put a end vertex. Activity H is 5, and I'm up to the last activity, which is activity I, and that flows out of H. So now let's finish H before we can start I. Once again, it's 5 days in duration. There's no more activities, so that sees the end of my project. So end or finish. Alright, there's the start, there's the end, and there's your network diagram. Alright, that's a you know, a real skill that you need to have there. Alright, so have I answered the question? Well, it's got construct a network diagram, which I have done, and then show the earliest starting times and the latest starting times, right here. So now at each vertex, we're going to be drawing like these windows. Okay, and then we're going to do a forward scan and then a backward scan, right here. So 0, to get to this point over here, I'm going to be spending 5 days, and then to get to this point over here, it's going to be 5 plus 15, which is 20. Now to get to this point over here, I can go 20 plus 25, which is 45, or I can go 20 plus 15, which is going this way. 20 plus 15 is 35. Now remember, activity F cannot start until activity C and D have both finished, and that's going to take 45 days. Alright, now to get to this point, I can go 45 plus 10. Okay, so going this way, 45 plus 10, well, that's going to be 55 days. Or I can go 20, so at this point over here, 20, plus 30, which is 50 days. What do I write in here? Well, I need to write 55, okay? And now moving right along, to complete activity G is going to take an extra 10 days, 65. Activity H will take 5 days, 70, and activity I is 75. So the minimum completion time is 75 days. Now let's do a backward scan. 75, take away 5 is 70, take away 5 is 65, and take away 10 is 55. So nothing too hard at this stage. And now 55 to when I take 55, if I'm heading back this way, all right, so 55, I'm going to take away 10, and that will lead me down to 45. If I head that way, 55 take away 30, okay, will give me 25, but I'm going to write that on the outside because I can get to this point coming from this way, or I can get back from this way. All right, now 45, okay, take away 25 is 20. Now remember, going forward, we were writing in the longest time. Going backwards, we're writing in the shortest time, so 20. Okay, and then over here, 20 take away 15 is 5, and then it's 0. All right. So all of that helps us when we answer our second question, which is what is the critical path? Now, the critical path is very, very easy to see, and it's where all of your numbers going forward and going backwards are exactly the same. So critical path is going to be through A, then B, then we went activity C, then F, then G, then H, and then I. So that's my critical path. Okay, and now it says identify any non-critical tasks and float times. So this is for part C. So this is for part B. Alright, so what's happened over here, so I might just use my highlighter and let's go green. Over here, okay, I got to this particular vertex, yeah, by going through A, B, C, which would have been 45 minutes, but going through A, B, and D was actually 35 minutes. Alright? So there's a little bit of float time for activity D. So activity D can be delayed. So what's the float time? The difference between these two numbers, well, it can be delayed by 10 minutes. Alright? If I delay activity D, because remember when I went this way, I arrived over here after 35 days, but I had to wait 10 days. So I can actually delay activity D by 10 days. Alright, let's have a look at the next juncture, which is over here. And let's look at these two numbers. Alright. So I could have gotten to this vertex over here by going through activity E or through activity F. Alright. Now going through activity F was 55, okay, and going this way 20 plus 30 was actually the 50. So there, alright. So in other words, activity E can also be delayed by how many days? Well, look at the difference between these two numbers, by 5 days. And that's the end of my presentation. I hope you have found it useful. I just want to encourage all candidates to keep on studying, keep on learning, and to prepare yourself as best as possible ahead of your trial exams and also ahead of your HSC exams. Best wishes always.